This is the third video in the trig substitution sequence. We have looked at substitution using sine and secant, and this video is going to concentrate on using tangent theta as a substitution. If your radical in the original problem has an addition sign between the constant and the variable term, then we're going to use the substitution x equals the square root of that constant, tangent theta. And then once we've made that substitution, we're going to use the Pythagorean identity 1 plus tangent squared theta equals secant squared to simplify underneath the radical and eventually take a square root. The example using this substitution, we have the integral of x over 4 times the square root of 16 plus x squared dx. Under the radical, we have addition, and it wouldn't matter if this was written x squared plus 16. Addition works in either direction without any issues coming up. So we're going to go ahead and use our substitution. The square root of 16 is 4, so we will have x equals 4 tangent theta. The derivative is 4 secant squared theta d theta. And when we go back to the original problem and make our substitutions, I am going to factor out the 1/4, and that'll get the fraction out front, and it won't be in the way when we start making substitutions. X, we'll just make a direct substitution, 4 tangent theta. Under the radical, 16 plus 4 tangent theta, quantity squared. And then dx, I'm going to write it underneath, but it's really all one line. 4 secant squared theta d theta. And let me highlight that real quickly. That part is that part. Okay, progressing. Actually, let me erase that. That 4 and that 4 will cancel each other. Underlined in blue, we have 4 secant squared theta d theta. There's still a tangent in the front. I'm going to put those together. Okay, so 4 from the blue part, tangent theta, secant squared theta. The order really doesn't matter. You just can't forget anything. You got to make sure you keep it all. Under the radical, 4 tangent theta quantity squared is 16 tangent squared theta. Okay, let's make sure we didn't forget anything from the line above. Okay, so we canceled the 4's from 1/4 times 4. That left a tangent theta, 4 secant squared theta. That's still there. Under the radical, all we did was square 4 tangent theta. It looks like we're good to go. Under the radical, if we factor out a 16, that's going to give us 16 parentheses 1 plus tangent squared theta. And then we can use that Pythagorean identity to change that to secant squared theta. Let's go to the next slide and do that. I am going to move that 4 in front of the integral symbol. factoring out the 16, using the Pythagorean identity. Square root of 16 secant squared theta is 4 secant theta. Multiplying everything together is going to give us 16 tangent theta secant cubed theta. Splitting secant cubed theta up into secant squared theta and a singular secant theta is going to give us 16 secant squared theta. So we're going to take those 3 secants and split them up into 2 and 1. I want to leave the secant tangent together because secant tangent is the derivative of secant. And so, like the second video, we can make a substitution using secant because its derivative is going to make up the rest of the integral. And this is going to reduce down very nicely. That's going to be u squared du. That has an antiderivative of 16 thirds u cubed plus c, going back, because now that we've gone from x to trig to u, we got to go backwards from u back to trig. And then you guessed it, we've got to go from trig back to x. Our original substitution, excuse me, was x equals 4 tangent theta. So if we, and I'm going to recopy from the bottom of the last slide, 16 thirds secant cubed theta plus c. And then let's recall x was 4 tangent theta. So that tells us x over 4 equals tangent theta. Draw a right triangle. Mark one of your angles as theta. I usually just do the bottom right. Tangent is opposite over adjacent. It's the TOA part from SOHCAHTOA. The hypotenuse is square root of x squared plus 16. Going back to our problem, 16 thirds. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent with respect to where theta is marked hypotenuse over adjacent. Plus C. Be careful not to reduce 4 into 16 twice, because that 4 is grouped and all cubed. That's actually a denominator of 64. Let me just mark that. I tell you what, let me just make one more extra line. Square root of x squared plus 16 cubed can be written with a power of 3 halves. 4 cubed is 64. Now I'll come in here and do a reduction. (16 into 64) 4 times. Okay, so that gives us 1/12, and this will be our final answer, y'all. 1/12 x squared plus 16 to the 3 halves plus C.